Hello, calculus fans. So we've looked at differential equations from a couple of points of view. We've done them graphically, where we've talked about direction fields. Remember, these were also called slope fields. And we also solved them numerically with Euler's method. And this gives us approximate solutions to differential equations. Now we want to try to solve some differential equations symbolically. That is, we want to come up with the function that is the unknown function. Now, not all functions have a nice antiderivative. They don't all have functions that you can compute antiderivatives of. It's actually not always possible to solve a differential equation symbolically. In fact, it's really very easy to write down a differential equation for which there is no symbolic solution. Now we're going to go over a particular type of differential equation that can be solved explicitly. So we'll make a definition to say that a separable equation is a first-order equation. Remember, this is one in which the highest order derivative is a first derivative. The expression dx by dy can be factored as a function of x multiplied by a function of y. In other words, you can write it of the form dy by dx is equal to g of x times f of y. Now, provided that f of y is not equal to 0, we can write this as dy by dx equals g of x over h of y. So here, h of y is equal to 1 over f of y. All right, so it doesn't really matter how we write these. The important thing is that to solve the equation, we're going to rewrite it in what's called a differential form. That is, we're going to put all the y's on one side and all the x's on the other. And when we do so, we think of dy by dx as a fraction. Now, dy by dx is not a fraction, but for the purposes of this, we'll think of it that way. And then we'll integrate both sides. Now, this is going to define y implicitly as a function of x. And the book is going to give a justification of the validity of this method. By the way, when we say it defines it implicitly, that means we don't necessarily have y equals some function of x. Sometimes we can solve for y, sometimes we can't. And we'll see a couple of different examples. Okay, that's all for now.